Why do we find this here? Limit, yes, okay. But why do we find derivatives? What does derivatives find for us? Good. So what a derivative will give us? Will give us the instantaneous rate of change. Which is the slope at any point on the graph. Okay, that's what it'll give us, okay? Okay, you take your books. Okay, does anyone remember what the equation is for the slope of a line using calculus? How do you find the derivative from first principles? I don't remember. So f prime of x is equal to limit of h approaches 0. All over h. Now, if you remember where that came from in the first place, I drew a picture, and I don't know if I'm going to, maybe I will for Tyler here. Where that came from, this is my graph of f of x. The equation is slope, right? So slope is just rise over run, okay? So my y values here are going to be f of x. This is x. That's f of x. I'm going to pick one point on my graph, and I'm going to call it, right here, this point is going to be x and f of x. Is that the point? Oops, I should probably do it. Everyone that was here before has this in their notes already. Okay, so this point right here is going to be whatever, w whatever. Just write w and f of w. Ah. But if I consider this gap between these two letters to be h, I can call this then this point right here to be x plus h and f of x plus h. And then using my slope, the slope equation was just f of x plus h minus f of x all over x plus h minus x. So it's going to be f of x plus h minus f of x over h. And that's sort of what I did there before. If this is coming back to you guys, that's where the original equation came from. Now we want instantaneous rate of change. Back from advanced functional from the beginning of the year. What does instantaneous rate of change mean? What's h going to be? 0, or close to 0 as we can get. Okay, and that's what this limit stuff is, and I'm saying this for Tyler here and everyone else. What we're trying to say is the gap between those 2 points is going to be 0. If you remember, probably in advanced functions, you do something like f of 3.001 minus f of 3. Remember all that stuff? Okay, we're going to ignore all that messy stuff. I sat last week in Mr. Lacey's advanced functions class last year. I don't know if you remember that. I'd sit at the back of the class and I just go every time you guys did those questions, okay, because they were painful. This will be much nicer. Okay. Let's go through some of our limit rules here just to make sure for a sec. What does 0 over 0 or infinity over infinity mean? Error. So start over. That's what it means. Okay. Let's say you have a number over infinity. What does a number over infinity equal? 0. Good. What does a number over 0 equal? Sort of. It means sort of. It's impossible, but something like 3 over 0 plus would equal infinity. Because positive over 0 plus, what that means is like 0.00000000 forever 1. Okay, so, and the same thing, 3 over 0 minus would be infinity. Did I miss any infinity rules? Did I miss anything? That's basically it for, that's it.
Infinity divided by a number.
Oh, right. Okay, so infinity divided by k is equal to still infinity. Okay, so if I say I have infinity dollars, I'm going to split it among 3 people, you still all have infinity, which is weird. Okay, right? But the same thing. If you ever say on the playground, and I'm sure at your mother's playground this happens all the time, I hate you infinity. Oh yeah, I hate you infinity plus 1. Oh yeah, I hate you infinity times infinity times infinity. In calculus class, what are all those things? Well, infinity, okay, that's it. Infinity is not an actual number, it's a concept. Okay, it's like the biggest conceptual number, it's something very, very big. Okay, let's do a few examples here now to make sure to find the derivative. I'll start off easy, then we'll get off. So example 1 is going to say, if f of x equals 4x squared minus 3x plus 2, find f prime of x. I'll do this one with you guys, and then I'll give you guys a chance to try this by yourself. Okay, another one after. Can someone please be brave and recite from memory the equation to find the derivative of the first principles? Yeah, go ahead. Of course, you said this, right before that. Good. F of x plus h. Okay. So, can I get someone, please, other than Evan, to sub those numbers in, please, and tell me what we get? I'm going to sorry, Todd, I'm going quickly. If you need me to slow down and explain, please be brave and ask. Okay, can somebody please tell me to sub in? Please play along. Here we go. Yeah. Can I do that? Is that okay? All over H. Now here's the thing. This is going back to Tyler here and everyone else here. If I sub in 0 directly here, what's going to happen? I'm going to get 0 over 0 right away. So what we're going to do here is use our great algebra skills to hopefully expand out the numerator so you have an x in the numerator. Sorry, h in the numerator. You have an h in the numerator and h in the denominator, they cancel, and we're happy. Okay. All right, who wants to show us our foiling skills? What's x plus h all squared? Go ahead. Two boards, I shouldn't even kid myself here. Minus 3x minus 3h plus 2 minus 4x squared plus 3x plus 2 all of h. Now please remember, if you've been in the class before, this is a level 1 difficulty question. Right, is this coming back? This is like, nice. Okay, we'll get to worse here in a second. Michael will go through the awful ones with you.
And when you're doing these questions, all the f of x terms should cancel out.
Yeah, and that's a good point here, okay? So what should happen is this f of x should cancel with the x's here. So all those are hopefully going to cancel here in a sec. I'm going to expand that out. That turns to limit. H approaches 0. 4x squared plus 8xh plus 4h squared minus 3x minus 3h plus 2 minus 4x squared plus 3x plus 2 all over h. Okay, Fanny, I hope your mind didn't expose us to running up the math contest. Are you okay still? Yeah. Okay, can you simplify the numerator for me, please? Then cancel.
H plus 4h squared minus 3h.
Okay, so the negative 2 crosses out with the plus 2. The positive 3, I'll just slow it down. And then we have negative 4x squared cancel with 4x. So Michael made a good observation. Anything with the plain x should cancel. Because when you're dividing by h, you want to cancel everything should just have an x in the numerator. So this is going to turn into equals limit h approaches 0, 8xh plus 4h squared minus 3h. Is that right? All over h. Okay, why are we finally happy? H is finally canceled. Okay, so we're going to say equals limit h approaches 0. 8x plus 4h minus 3, which is equal to 8x minus 3. How did I get that last step? What did I do to get that last step? Okay, h is equal to 0. Is it starting to come back a little bit, I hope? It never left. It's in your nightmare still. Not to mention names. Did I tell you there was a girl in my other class that said she was working on her choice assignment? And she was really struggling hard to get the question before she went to bed. And she woke up in the morning and said, clearly x squared minus 4x minus 5 equals 0. It just came to her in a dream overnight, okay? So hopefully you won't be dreaming about calculus too much. Feature vector serial in the morning, be thinking about vectors and all that. Okay, I'm going to pick a slightly more difficult question. I'm going to give you a few minutes to solve it, and then Mike will take up the solution. Are you guys ready for a little bit worse than that? Yes? You want a lot worse or a little worse? A little worse.
Something.
Okay. How will we use a fraction? Example 2, let's do a fraction. If f of x equals, we'll say 3x squared minus 4 over x plus 1, find f prime of x. Is that good enough? Okay, we'll do square roots and all that stuff will come after. Okay, right? Does Stefan come back, I hope? Yes? Okay. I'm going to sit with Tyler to make sure this is all good. And then